So in the previous video, we have talked about string, right? Now we talk about this string. What might be happening behind the scene? Example, let's say if you store this Navin, of course, it will be getting stored in the heap memory. But now what I want to do is, before printing Navin here, let's say I want to append something. So let's say I will say name is equal to, I want to add my name with, let's say, Reddy here. I'm giving a space so that we can differentiate these two words. So of course, now when I say name, it will be Navin Reddy, right? So basically we are trying to change the value. Now if we talk about integer, float, double, basically you can change values of it, right? And it actually makes sense. That's why we call them as variables. And here also we are trying to do that. But first of all, let's check if this works. So if I go back and compile and run, it works. You can see that the new data for the Navin is Navin Reddy, right? And that works. But what if I say that's not the case? You're not changing the existing string. Let me repeat. You're not changing from Navin to Navin Reddy. So if you're thinking there will be a variable here where you have Navin, you're making it Navin Reddy. No, that's not the case. That's not how string works. Okay, so what happens? So what I will do is I will just remove this part now. So what is happening basically? Since strings are used heavily in Java, now most of the time you try to reuse the strings, the same string. You'll be using multiple times. Example, let's say, if before I show you something, let's say I create a string here, which is S1 is equal to Navin. And you can see we have a capital N this time. So these two data are actually different. Okay, so I will say string S2 is equal to, and I will say Navin again. Now, what do you think? How many objects we are creating behind the scene? Think about this. Okay, so if you're thinking we got two objects, actually not. We got two references. We got S1, S2. Of course, in your stack, you'll be having S1, S2 here. But in total, you got only one object. I know that sounds tricky here, right? And let me prove that point to you. See, what I want to prove is the value for this field and this field will be equal. The way I can do that is by saying Sout S1 is equal to S2. If this is true, then they are same. So if I run, you can see we got true. That means the value for the addresses are same. In total, we got only one object. So here, what happens is we have a special area inside your heap memory. So this is your heap, that's your JVM, and that's your stack. So inside your heap, you will be having a special area called string constant pool. And by the name itself, you can see it says constant. That's right. Every string which you create, which you use in Java, which is a string literal, is actually a constant. You can't change it. Example, if I write something like Navin here, I cannot change it. It's done. It's Navin everywhere. Okay. So you can't change the data. So example, what happens is every time you try to use a variable here, example, if you execute the line number 8, it checks, okay, we need Navin variable. Do we already have Navin in the string constant pool? No, we don't have it. So let's create Navin here. So it will create a string variable Navin. It will have some address, let's say 101. And then the name variable here will get this address. So this name variable is actually referring to this particular address. Okay. Then it goes for the next statement. Let's execute this part. Let's ignore this line as of now. Let's focus on line number 12 and 13. So line number 12 says S1 is equal to Navin. Okay, so it checks, do we have Navin with capital N in the string pool? No, we don't have it. So it will create Navin here. And let's say the address is 103. So it will store 103 here. Okay, now that makes sense, right? And that's why it is referring to that particular location. Now, what happens on line number 13? Line number 13 says string S2 is equal to Navin. It will go to string constant pool again and check, hey, do we have Navin with capital N? Yes, we do have. Now, it will not create a new object for you. It will simply use this address 103. Okay, and that's the beauty. That's how you're trying to save the memory. Otherwise, you could have created multiple variables with the same data. So it doesn't make sense, right? And that's why it uses a string constant pool. Now my question to you is, what is happening here? Now, when I say you can't change the data, that means you cannot simply update this particular Navin by Navin Reddy. No, that's not happening. Navin is still there. It's a constant. You can't change this. Now on line number 9, what is happening is it is creating a new object which will have a data which is Navin Reddy. Let's say it has the address which is 105. So on line number 9, basically what you're doing is you are changing this address from 101 to 105. You're just changing the address. You're not changing the actual data. You are basically creating a new object. Okay. Now you might be thinking, what will happen to Navin here? The thing is, now this particular object is eligible for garbage collection. It will be removed after some time, just to get some memory back. Okay, so point to remember is, once you create this object, you can't change it. And that's why we have some terms to remember. And the terms are, so there's a concept of mutable strings and immutable string. Now what is mutable means? Mutable means change, something which can be changed, and immutable means unchanged, or you cannot change it. So basically by default strings are immutable. Once you create the object, you can't change it. And that's very important to remember. It's immutable string. Okay, so whatever data you're creating here is immutable. But what if you want mutable string? And that's why we have two different classes in Java to use. Instead of using string, you can use something called a string buffer or a string builder. Now both are very similar with one difference. That difference we'll discuss later, but they both are similar and they both provide you a way to implement an immutable string. Okay. Now how do we do that? That we'll see in the upcoming videos.